All right, I am so excited to be here. I think it feels so good to be in person with people again. I'm not sure how you guys feel, but it feels like it's been a long time, right? So what I'm going to talk to you about today is I've got some great stuff about Google Cloud and services we offer at the end, but I wanted to start off with a story that I think is going to sound really familiar to a lot of you. We'll see if I can figure out how to use this. Yeah. So to start off with, what is Google's application story? So when we're talking about application modernization, it helps to know what Google's roots are. And I don't know if you guys know this, but we have 9 products with more than 1 billion users each. So starting with Google Search, released in 1997, all the way up to Google Photos in 2015, all 9 of these products have exceeded 1 billion users in breadth and scope. So we have been a cloud company from the beginning in that we've had to scale and think about how you do things globally and so on. Now, what's interesting too is in 1997, machine learning was not a big practice. Certainly there were people working on neural networks, all of the math, the linear algebra, things like that to solve systems of equations, the calculus. It was all there, but it wasn't machine learning. We didn't have the computational complexity and sophistication to actually make it work. And what Google has done over the years is we have reinvented all of our products to incorporate the latest in machine learning. And it's breathtaking to see when you look at what DeepMind has brought to Google Search, where it can identify the parts of speech and the intent of the user in what they're trying to find as part of the search process, which is why people continue to come to Google every day to search. Or if you look at Google Photos, one of our more recent additions to the billion user club, you can just type in a word like swing set or car, and it will pull up all of your images across your entire history of images with things that match that. So it's fun to see that. Now, another thing that you might not know is that we have been using containers to deploy applications since 2006. And just to give that a little context, Docker was released in 2013. So we were using containers for years and years, and our Borg implementation, which was actually what we used to design and develop Kubernetes, is something that has been running our production workloads for quite a long time. And in fact, everything at Google runs in containers, whether it's Gmail, search, maps, and so on. Even in Google Cloud, the VMs are running in containers, powered on the back end by our container technology. And this slide is a little bit old. So I'm sure this number is higher. I reached out, I couldn't find a current number, but as of about 3 years ago, we were launching 4 billion containers per week. So that's a fun kind of fact to orient around what is Google, what is our application story, and what can we bring as far as modernization. So now this next bit of the story, I think is going to sound really familiar to everybody, right? So what is modernization? How is it done? I think a lot of you have seen a version of this slide. Right? So on the left side with the blue arrows, that could be termed infrastructure modernization. In other words, I've got depreciating or deprecated hardware in the data center. I need to get to something newer. Do I go out and buy new equipment, put it in the data center, depreciate it over years, or do I move it into cloud? And this is a really popular migration, even if some people don't think it's a very good option, which is fine. The idea, though, is that lifting and shifting apps can be a really effective play, right? And as our Microsoft friend, who's not here anymore, was talking about, it's hard to beat the security in cloud. There were a number of things talking about security, and I don't have any slides on this, but Google, our security story is so compelling. It's so far-reaching, where we protect at every level. Even when it comes to the network, once you get on our network, because we have invested so heavily in global fiber optic networks that we own, once your data gets on our network, it never leaves our network. So you're not worrying about jumping around across ISPs and your data potentially being intercepted or managed somewhere else. So lift and shift, and lift and optimize and shift, that's a compelling story. It can be. And I'm not going to talk about that today. Now, these green lines, move and improve or improve and move. The idea that you say, I want to get closer to cloud native, and I definitely want to get into cloud. What can I do with my applications, my legacy applications, where I don't have to do quite as much work, but I can get them closer to cloud native. I can get more automation. We talked about automation today too. And then obviously rebuild. So Greenfield, this is easy. A lot of you say, oh yeah, if I'm starting some brand new app, I'm going to make it cloud native from the beginning. Sometimes that works. Sometimes. And rebuilding legacy applications so that they are cloud native. Sometimes that works too. Now, there are a lot of things we can do to make that successful. And that's what this is about. So I think that these next few slides, I'm going to go kind of quick through them. I'm guessing that everybody in here is just going to spend the whole time nodding. You're going to be like, oh yeah, right? So everything with application modernization begins with the application, naturally, right? And this application needs to be hosted somewhere. If we go far enough back in time, that was a physical server, right? Today we have some other options. We're going to get to those in just a minute, by the way. So the software engineer, what does he care about? He cares about the application. Does he care about the server? No, he doesn't, which is why his best friend or worst enemy is the system administrator, because the system administrator, he cares about the server. He takes care of patching it, taking care of it, and so on. So far, this is a pretty familiar story. Now, as we get more applications, we have to build out more infrastructure, more space for those, and we end up with data centers. And once we introduce a data center, we need a data center operator. We need somebody who's worried about what are the physical connections coming in? What is the power? What's the state of my UPS? All of these data center concerns that don't have anything necessarily to do with the server or the application, but he's definitely a part of this story. And now networking, as it gets more complex, the redundancies and the mitigations for different types of issues that come up, you need somebody who is the network admin. And I gave him a little Zeus tie, because who do you always blame first?
The network guy.
And who is never responsible for the issue? The network guy, right? I mean, so he gets to sit on the top of the mountain and say, no, it's something else. You know, it's Verizon, it's the application, it's something else, right? But he's got a part in this story. Now, what's cool is we thought these servers are getting so big, I don't need 24 CPUs and 2 terabytes of RAM. Let's virtualize this thing. Let's break this into pieces. And the software engineer, he gets to keep doing the same thing he was doing before. What about the sysadmin? He gets to keep doing the same thing he was doing before. But as virtualization gets more complex, now we need somebody to administer the virtualization, right? So you can see we're getting quite a few players in here, right? Now, as all of these pieces and people start coming in, we need to think much more about security in depth and breadth. So the security guy, he's got to come in and be part of this. Monitoring also grows in complexity. So we've got to add people for monitoring, you know, capturing logs, storing logs, searching logs, as well as network events, you know, physical security of your data centers and so on. Audit, government and regulatory, is the government and regulatory situation getting simpler or more complex?
More complex.
More complex. Is it ever going to get more simple?
No.
It will never get more simple, you know, until the volcano erupts and we reset. You know, maybe that'll do it. But until that happens, auditing is a huge piece of our technology landscape. What about consultants? We realize, you know what? We just can't hire enough people with all of these skills. So we're going to start bringing in consultants. Now, what about contractors? Yeah, you know what? I don't need somebody full-time for this, or I need people that are going to be a little more flexible. So let's throw some contractors in there. Oh, we need some vendors. We got them out in the hall. You guys are going to spend a little more time with them after the meeting today. Well, what about software as a service? That sounds awesome, right? Yeah, so we've got software as a service. And now we start to get some of these cost and operational benefits out of our data applications, which is awesome. Oh, appliances. Hey, this sounds great. You mean I don't have to have server space or rack space that I'm buying from one place, buying software from you, administering it myself. You're going to send me the whole thing. I plug it in, it starts doing its thing. Okay, well, what I think you can see is that our little image that we started with on the left there about modernization is not a technology problem. It's a people problem, right? So how do you work with all of these people to come up with a compelling story around modernization? Why does modernization matter to the software engineer? What does it look like to the software engineer? Why does it matter to the sysadmin, the data center operator, security? And a lot of these people feel like, oh, you know what? Where am I? Where do I fit in data modernization, in infrastructure modernization, in application modernization? And these are really valuable questions. So this is a people problem, first and foremost, that we're trying to solve. And I like to start with this because I think a lot of people say, oh, hey, yeah, how do you modernize? And they point to their serverless platform. They point to their data lake. They point to all of these technologies, which are great. What I'm saying is, how do you get these people to listen to you and think, you know what, there's value in looking at something different than what we do today? Okay, so an example of how modernization works in the enterprise. Does anybody want to comment on this? It's pretty familiar so far. Okay. An example of how modernization works in the enterprise. So a company I worked for a while back, TriNet, so I'm intimately familiar with this, but it shows a lot of these modernization kind of problems that you encounter as you go forward. A 30-year-old company. So they have legacy applications that they wrote 30 years ago. They have modified commercial off-the-shelf software all over the place. They've got mergers and acquisitions that have brought in servers that they have no idea how they work, and they're just trying to tiptoe around them to make sure that it doesn't turn off or stop working. Okay, so they had a pretty traditional kind of flow from physical servers to, and by the way, where do physical servers start? They started under the desk, and then they got moved to the closet, and then they got moved to the garage, which overheated, and then they got some air conditioning. Like we know how we got to data centers, right? But so they started with physical, they went to VMware. That's a pretty consistent move. And then they thought, hey, you know what? We're going to save some money. We're tired of giving all our cash to VMware. So they started using OpenStack. And that's when they brought me in and they said, we've spent 2 years trying to automate the deployment of our technology on OpenStack. Can you help us get across the line? And I came in and I looked at it and I said, well, I think we probably could do some things, but I don't have any idea why you would want to. In other words, containers give such a compelling reason to come in for the cost savings, for the automation, for the security, for the immutability. There's just so many reasons that containers were a better story for them. And so we pushed in that direction. Everything was on premise and they were very cloud cautious. Anybody in here ever met somebody who was cloud cautious? You guys know what you know what I'm saying when I say that, right? I don't know if I've ever heard anyone say it just like that, but like, oh, no way, man. There are so many reasons that we can't go to cloud, and they like they lift up their hand, like they're going to start counting them off and they're like security, network, and then they kind of run out of steam and they're like, yeah, but they're out there, man. Like so many reasons why we shouldn't be going to cloud. Okay, so they were definitely cloud cautious. They had a big monolith. In fact, they had a few monoliths. And they're like, hey, we've heard all this stuff. We love Martin Fowler. We read his books. We need to be microservices, right? And so they were working on refactoring their monolith to microservices, which maybe I might call it a microlith, because a lot of people when they're moving from monolith to microservices, they well, anyway, you know how those go, right? I'm sure you've all been part of one of those. Now, and from their technology, the languages, the ways that they built and delivered their software, they had everything from COBOL to Java, right? And everything in between. So it wasn't just oh, hey, yeah, we can come in and do Java, we can come in and do PHP. It was just about everything that you could imagine. So when I came to this problem and started to ask this group, okay, what do you want to get out of this? Are you looking at cost savings? Are you looking at speed? Are you looking at security? Are you looking at agility? The answer is yes. Every one of those people in that diagram that I was on the other, they're looking for one piece of that. And to them, their piece is the most important piece. And to them, they have veto. Like, no, this doesn't make sense to me. We can't do it. And unfortunately, a lot of organizations get stuck there. So the first thing I had to do is kind of coach a lot of people around what I call reframing the conversation. What was happening? This was happening a lot, and this happens in every company. Some technologist comes along and says, hey, you know what? We could do this better, and then they describe the better way. And they go to management, they say, hey, I'd like to do this. And management says, yeah, well, we don't have the resources, we don't have the time, we don't have, and they went down their list of all the reasons that this just didn't work out. So what I did is I said, stop asking. And this takes some risk. Modernization requires risk. Now, what I said is, you do something. Go in and implement a small part of what you want to do. You're going to get your hand slapped, but that's exactly what you want. Because if you walk into the manager's office and say, hey, I know we've been delivering this on VMs for years, but I put it in a container and it's running over here and I think it'll be great. The manager's going to say, well, what were you thinking? We're not ready for containers. And now the manager's going to yell at you and say, here's why we're not ready for containers. Did you think about this, this, and this? That's the conversation you want to have with the manager. He just gave you a list of everything that would qualify containers to go into production. So you just take notes as he's yelling at you, but now you're having a different conversation. So the first step in modernization is, take care of the people, think of what they want, but then reframe the conversation. Stop asking, can we do this? Should we do this? How do we do this? And take some action. And then let the awkward or the tense conversations follow that action into a conversation that's productive about moving the technology forward. Now, reducing operational overhead is a big thing. If you remember all those people on that slide previously, that's a lot of operational coordination that has to happen on a daily basis, right? You've got people coming in that, hey, I'm about to make a change to the network. Oh, I'm going to change the application. Oh, we're changing the way we're capturing monitoring or processing logs. There's so much operational overhead that's a result of just coordinating activities between all the people in there. And so what you want to do as you're modernizing is say, how can we reduce that operational overhead? And cloud is a brilliant way to move toward that. Automate as you go. And what I would say is automate iteratively. You don't need to tell your whole automation story before you get out of the gate. You want to come to automation in a way that says, hey, I can automate this much. In fact, I have another slide. It's not in this deck, but in it, I argue that cloud native is not a thing. It's not binary. You're not traditional or cloud native. It's a spectrum. And virtually no one is 100% traditional. I mean, if you have a script, a bash script that does some stuff to a server to get it ready for your application, that's automation, right? And virtually no one is what we would call 100% cloud native, where as soon as a code commit happens, everything cascades down to it being ready in production after some amount of time. So the question with automate as you go is, can I move closer to cloud native? And don't get hung up on trying to get all the way there. Be opinionated. I think this is really important. I think a lot of enterprises I see they spend a lot of time trying to say, oh, well, we could use this, we could use that, we could use this. Start somewhere. And guess what? You're wrong. Every single time, there's going to be something about the solution you choose that is not going to fit your technology, your business strategy, or whatever, right? No matter how much thought work you put into it ahead of time. So just embrace that and say, let's be opinionated. We're going to choose something. Favor action, move into the future, and then identify what worked well about this, what didn't. I'm going to talk more about that in a minute. Treat everything as code, especially your infrastructure. So whether you're Terraform or CloudFormation or whatever other automation technology you have, you want to make sure that it can be written as plain text, that it can be stored in some type of a revision control system, that you have appropriate, histories and controls around that. But yeah, whether it's defining what a server looks like, what a container looks like, how deployments happen, your tests, everything should be as code. Make it easy to access. This is another big problem in the modernization journey with a lot of enterprises, is that you end up with a few gatekeepers, and those gatekeepers want to come in and say, nope, you can't use it, or we have to have a meeting, or we have to have some big approval process. And so the more you can get those decision makers out of the way, or rather get them on board with, we want people to have access. How can you, so here's the question you want to ask. How can you feel comfortable automating access? And if they say, well, I want more auditing than would ever be possible, then you start building the auditing and you make access easy. The more access your technologists have, the more they will surprise you with what they can deliver. So they need access. And know what matters to each stakeholder. We've talked about that a lot. And build to your strengths. So if you've got a lot of background in one open source technology, ask yourself, how can we leverage this as we move into cloud, as we move into modernization? If you're in Java, there are lots of tool sets. If you're in Ruby, if you're in Go, there are lots of different patterns and frameworks and things that are available that can help you move into cloud. Okay, so what resources, and how much time do I have?
Oh, you still have about 10 minutes.
10 minutes, great. Okay, so we'll spend a little time here. What resources does Google have to help you get there, right? So the first one I would say is that culturally, Google has a really amazing and fun story. And one thing that we have given to the world, and by the way, Google publishes way more than we probably should. In fact, most of the NoSQL databases, a lot of big data, distributed file systems, all those technologies came as a result of us publishing scholarly papers on how we arrived at those decisions and even reference implementations, to the point where now we're publishing our findings, our scholarly research, and our open source reference implementations at the same time. So site reliability engineering was something that started at Google, and culturally it says, I'll try to summarize it, but you guys would definitely benefit from looking into this. A target of 100% uptime is the wrong target almost 100% of the time, right? So in other words, your system will fail. And site reliability engineering says, why don't you take advantage of that fact? That idea that this system will fail, and look at your users. Look at them and say, what is their expectation? Do they really need this system to be up 100% of the time? So you find that merge point between user expectations, what's possible, and you say, okay, well, I know I'm going to have about 2% downtime. How do I spend that budget? So the question is, how can I take risks that will allow me to move forward and fit within that 2%. And once you reach 2%, then you can fall back into conservative mode until you get more error budget. But if you're going along and you're not accumulating any error budget, it means you're not moving fast enough. You are missing opportunities to deliver value to your end customers. So yeah, site reliability engineering is great. There are two resources here. There was a large enterprise customer in the oil and gas industry here in Houston. And last year, I delivered a 2-day site reliability engineering workshop to about 60 or 70 people in their organization, teaching them how it works, walking them through a workshop, and then actually helping them apply it to specific projects and work streams in their business. So if that's something you're interested in, reach out to me after. But this is, these are available for free. You can go read them. You can buy them. They're O'Reilly books, really high quality stuff here. Okay, now cloud, this is the other thing that's neat about it. It makes it possible to stop thinking about applications and data centers and instead focus on the workload. right? So in other words, rather than saying, oh, hey, I've got this application, you can just say, I have a workload. Maybe this workload is a machine learning algorithm that's doing inference. Maybe it's a BigQuery table that I'm running machine learning in. It's powering my data lake. Whatever the workload is, you want to get to the point where your workload owner just gets to interact with the platform. And the platform admin, which maybe it's a human, but maybe it's not, says, yeah, here's the platform. Here's how we provide safe, reliable access to this. Here's how we protect it. Here's how we drive our company strategies and so on. So Google Cloud Platform makes it possible to think about the workloads. One way that we do that is with our serverless technologies. And nothing I have here is quite as comprehensive as some of the other slides I've seen. So definitely reach out to me if you're interested in hearing more about this. But serverless is a really great story, because what it does is it allows you to say, hey, I don't want to worry about the networking. I don't want to worry about the data center. I don't want to worry about the operating system. I don't want to worry about patching. I don't want to worry about vulnerabilities. I just want to write my application and give it to a platform and let it run. And so on all of these, not only do you get that, whether it comes from data or just the orchestration, the running general compute and so on, but you get that in the context of Google's security story, Google's data story, all of these things. The other thing that's neat about all of these is that Google is in a unique position in the cloud market, in that all of the technologies we bring to our customers already work on 9 billion user applications. So you don't have to worry about scale. You don't have to worry about whether or not Google can come with good guidance around how these technologies work and how you can use them, efficiently. I mean, even some like our Firebase platform. I'm working with one customer that they love it because it's so inexpensive to use. And they get all of the goodness of serverless for their database, for their applications, for their mobile, everything else. So our serverless platform's great. And then I think everybody here, there's not going to be any surprise that Google is the clear leader in artificial intelligence and machine learning. And our platform accommodates everyone from the solutions that like contact center AI that allows our customers to basically allow our artificial intelligence to answer the phone and interact with customers, to place orders, to schedule visits, things like that. But all the way down to using the frameworks that we release to open source, like TensorFlow. So whether you're operating at that base level, you are a data scientist with a PhD, you want 100% control, or you're a business user and you just want to come in and say, I need some vision services, I need some speech or text services, or special applications and everything in between. There's definitely a lot there. And I would say reach out to me if you guys have any questions or want to talk more about any of this. I obviously didn't include quite as many slides about Google specific services, but what I hope you walk away from this discussion with today is an appreciation for the fact that our approach, our process for getting to a more modern technology landscape at our companies is not about the technologies we choose as much as how we work together as people to move toward a better future, right? Because there are people who are going to have questions and concerns. We need to answer those concerns, right? They need to know that this is meaningful and valuable. And if it's not, then we need to find solutions together. So focus on the people, reframe the conversation, take some action today and modernize. You guys are going to do it. Thanks so much.